Hi all, my name is Mads Barnkopf from Kaizer Power Electronics. This is part 3 of the X-ray system teardown. This is the Siemens Polyphos 30. Now this baby is packed with lots of goodies, lots of technical, electrical, neat little details. So this will take a long time. So I say to you, grab a cup of coffee, because this will take a while. Before starting to just tear this down, let's just take a look at the goodies. I mean, just look at this. Rack-mounted computer, rack-mounted power supplies, high voltage inverter, power section. Let's see the backside. Here on the backside we have the power inlet. Just look at the size of this cable. It's taking a whooping 35 ampere main supply, 3-phase 400 volt AC. Large electrolytic capacitors from the rectifier bank, control transformer. This is possibly a discharge choke to the SVR inverter, but check this out. This is insane. The wire nest in the backplane here, that's just mind-blowing. It's just single wires running everywhere. And I don't have a manual. And here we have the main control panel. There's the on-off switch here. Everything is small touchable keys here, or you hear the clicking sound. You can adjust the millisecond. Yeah, kilovolt. This is for different programs, for different parts of the body. You can also choose thin, less thin, normal, thick, much thick. And that's minus and plus milliamps. So, thicker people needs more X-rays. Now, let's pop this baby open. Check this out. This whole unit is just made to be serviceable. It's insanely nicely engineered. Check out this board. That is a small test board. You actually have here all the symbols for the different parts of this X-ray inverter. Here you have input from the high voltage head with the X-ray in it. You have current, voltage. You have different inputs from the panel here, and it all shows that you can start the X-ray filament. You can start the rotating anode. All kinds of stuff, just to plug in straight to the computer. It is time to try to switch the unit on. I hooked it up to mains 3x 400 volt AC. So let's plug it in and turn it on. And just for the case of being precautious, I'm using ear defenders and glasses. Don't want anything to go flying. Or I don't mind it go flying, but I don't want to get hurt. Okay, so it's plugged in. Let's try to switch it on. At least we have one green LED here that came on. The whole power supply board down here is not, or the control panel not showing anything. It did make a thumping sound, but I think that was just from a contactor. So let's try to turn it. Nope, nothing. It also took the main fuse, so that might explain it. I'm going handheld right now to show you a bit of the details. As you can see now, I have opened all the service doors or swing out frames here. And as we can see, this actually makes it possible to get into the power section of the system. So all over here is all the connectors for different parts outside the system. So either this system did not use many peripherals, or else something is missing, because there are not many connectors actually here. But other than that, this is extremely top heavy, so I had to screw it down into the pallet in order for it not to trip over. As you see, it's leaning a bit still, so I'll get it back into place, and also had to place a huge transformer as counterweight over here. But yeah, this should make it serviceable if it's mounted up against a wall or something like that, so you don't have to take the panel out if it's mounted securely. So let's take a look at the computer. I have not been able to locate any CPU card, but at the first row here we have 6 cards with a lot of ICs on it. Then there was the display or control part here that I took out. Those are just flat cable connectors going to the control panel. Then over here is a few more IC boards, but also has a few switches on it that says something with test. Down here is a programming board along with another prom board. But other than that, here is power supplies for the SVR drivers. These are the SVR drivers. We have the white wires going down to the silicon here. And over here we have the main power supplies for the control voltages. So we can just start by pulling out the first card here. As we can see here, it's all Siemens numbers and it's all 40 series ICs. What I did try to do was locate a board that had a crystal on it, because then at least we could say that that was the main board with the main frequency generator or something like that. But as you can see, this is just all normal TTL logic. And just keeps going and going and going like this. So I'm not quite sure if this really has to be as simple as possible control, since it is an X-ray system, that there is no program. Just when you think back on the whole programming era thing with the X-ray system that actually killed a lot of people because of programming errors, that it overdosed people with X-ray radiation. That could be a main reason why this is all made in logic circuits and not a programmed computer. This actually has a bit of description. This is measurement points for the different control voltages, then kilovolt, feedback, the filament for the X-ray tube, then there is the milliamps and also the kilovolt more measurements, and that's voltage and current is and should be. So that's to compare something on the control panel. Here's another, this is the board with the test buttons on it, but not really any CPUs on it, all 40 series logic again. Another here, it has some large diodes on it, and all this are relays, it's not crystals. This is another, this actually has a lot of 80 parts on it, so this should be an analog to digital conversion board. Okay, so now we get down to an interesting board here, because this is most likely the CPU, but there is no CPU on it. But there is some prompts, so there is likely some program in it, but I'm not really finding a CPU to execute it, so I'm still not quite sure what runs this unit. And unfortunately I have not been able to get a schematic, since Siemens has pulled off any thing from like Frank's hospital service and such. There are no manuals to find. Now this is quite interesting, because this actually has a label. It says Programmeinheit, which is German for programming unit, and it has 3-4 jumpers put in it. But as you can see, it has a lot of rows to actually adjust this unit, select different options and peripherals and such. That's quite quite old school and quite some input heavy setuping. Then we come to two identical power supplies here for the SVR driver circuit. I guess there's one for each half bridge, or one for the upper and one for the lower side of the bridge. Then we have the control boards for the SVR driver circuits. So these two, they're not quite identical, but they has to do with the two output boards that, or the single output board that we have here. So you see it has the heavy wires connected to it. But there aren't any really output ICs. It seems to be driven directly by maybe these ICs, or not quite sure. Let's check out the last here that could be associated with the driving circuit. And yeah, just a large relay. But other than that, yeah, it's quite impossible to say what these boards are because there are no labels and no manual. Okay, this is blocked a bit. Quite funny that this power supply card is held in place, but nothing else is. So I'm not quite sure what kind of power supply this is. It says ground in and out here, but no specifications of the voltages that it produces. Another similar linear regulator here, probably low voltage, high current. Over here we probably have the plus minus 15 volt for the up amps and such. And this looks like it could be the main control voltage power supply for something like the 24 volt and 12 volt. So that was the content of the rack computer. Now this is some action shot, huh? This is the single wire backplane of the computer and control logics. And this really requires some schematic in order to tell what goes where. But it does have some easy disconnectors here, so you can actually just change the whole computer in one setting. That's quite neat. There's a small, simple single wire and one over here going up directly to it, else everything actually connects through these two connectors. Now we're down into the power section. In the middle here we have the inverter, the high voltage inverter, so let's just get rid of this warning sign. And what we have, this was the SVR driver board that we had up here, so we can follow the white wires. It goes over here, back and around. Whoa, where does that go? Guess we have to remove that board as well. 4 SVRs, as we have 4 pairs of wires going out of the driver board. And behind this board there's also a huge white fuse, which is probably to protect the SVRs in case of a short circuit in the X-ray head. But that's a huge fuse to see in a silicon protection job, because what kind of short circuit current are these? Well, generally SVRs can take much higher short circuit currents than modern IGBTs or MOSFETs can. So it is no surprise that it has a big fuse, but that is without a doubt the biggest silicon fusing I have ever seen. Just look at that. It's like the size of it's bigger than my fist. But as we can see, we have the large ones here. We have one here, and then we have an identical pair at the back side of the inverter. Now I would wish we could get this out, but I think we have to tear down the system a bit more to get in contact with that. Down here we have first all the upper row fuses here are all for the control section. The first 3 fuses were connected to outside peripherals, so that could be, for example, the lamp and the X-ray head for the collimator, or some other smaller motors for driving the different parts, like the cassette holder and such. Then over here we have internal wiring, which is all the yellow. So these are for the control voltages inside the panel. Up here we have a 3-phased rectifier bridge for a 564 volt DC for the DC bus for the inverter, which we could see on the back side, the large electrolytic capacitors. Down here we have the 3 main fuses for the main supply. Then there is the small power supply and fuse board down here. That is for all the different, the large control voltage transformer that we had on the back side, sits behind this PCB. And down here we have small automatic miniature circuit breakers that can be reset. This is 5 amp, 2, 2, 2, and then a lot of different melting fuses as well. So the inverter drawer here could be taken out, just had to find the right screws. So we have the supply voltage coming in over here, goes through the large 224 amp fuse here, goes directly over to one side of the bridge, and we have a small capacitor here, which that's a smoothing capacitor, or is it a output capacitor? I'm not quite sure. Let's see, that wire comes from the supply and the other goes over here to one output of the bridge. The other output of the bridge goes back there as well, so that probably goes down to the large capacitor on the back side. But we have some Simicron SGRs sitting here, 4 of them. So here we have the lower part of the bridge and the upper part of the bridge, and we have the 2 outputs here in the middle. Now the reason there was no driver ICs as such on the driver board here is because they sit on a PCB down here. And this is where the wires to the single SGR sits, and we can also see the red driving transformer that sits down here on the board. Now these Simicrons are, let's see if we can see a part number, SKT 111F09DS. So I'll just slap a datasheet of those up. Can't really see the specifications of this capacitor, but it is probably a 2 or 3 kilovolt. Can we see from the standoffs on the connectors there. The back side of the power section, over here was all the connectors to the peripherals and outside units that we have all the cables for here. Then we have the main DC bus capacitor here. That's 2 6000 microfarads, 350 volt DC in series. We can see they are connected in the middle here. So that gives us 3000 microfarads at 700 volt DC. This is the main control voltage transformer. It gives all the different voltages, so that's quite handy. Can be used to for some other projects needing a lot of different voltages. So yeah, I'll have to see what the backplate says once I get the whole fuse board out. Then the 2 main contactors here. One switched on the moment I turned the key, and the other one is just in series, so that might be the main supply up to the inverter once that is deemed good and ready to go. Now the DC supply up to the inverter is not just directly from the electrolytics, it actually goes through a LC filter here, that we have a high voltage capacitors that sits in series with a SCR or rectifier diode here, up to a very heavy inductor here. So that's either to smooth out the current pulses when drawing power from the power supply, or just a band pass filter or low pass high pass filter in order to protect the power supply from the switching noise from the inverter. The system can now be seen here in a exploded view. Got parts everywhere. So let's take a look at the different parts that we couldn't see before. Now up under the underside of the control panel, notice these small boxes here. That's actually for the lamps, so they can't light into the different lamps on the next to it. So we take a look on the underside here of one of the boards. We have the LCD segments for the measurement value here. Those are actually incandescent bulbs. And these push buttons, I thought they were normal tactile push buttons, but actually they are a small switch with a incandescent lamp next to it, and it gets into that little port there. So they can actually light them up from the side and get a very even light into it that way, and also shield it from lighting up other buttons. So there is really just so much thought behind anything in this. Here we have the main on-off selector switch with a little belt drive to this huge rotary switch here. Heavy duty brass contact out there, very nice. Now the control power transformer that we had down here, unfortunately it does not have any markings for the voltages that it has, but at least we can guess that the higher or the bigger wire gauge, the higher current. So maybe I can guess on these being the plus minus 15 volt DC, and then we have the 24 and plus 12 volt and plus 5 volt on some of the other thicker wires here. Some of the other parts that can maybe be used to something is, of course, the SCR inverter bridge here, but it's mostly peculiar parts. It's really dated and can't really be reused for much in today's modern world, where I can get much better parts. Yeah, pretty cheap indeed. So other than that, some ceramic fuses and holders, some power resistors, and then we have the large electrolytic capacitors, and then this was the filter before the SVR driver, which is a film capacitor, MKV type, 100 microfarads. But as we can also see, these are dated 84, 85, so those are probably also at the end of their life. The rectifier packs here are SKKD 31/40, so those are 1400 volts, and I'm not quite sure, is it 31 or maybe 81, but maybe it's just 30 ampere rated breaks, but they're useful. They can still be used for normal mains rectification. Now I will of course take some pictures of each of these boards so you can inspect them in more details. But other than that, I guess we end here. I hope you enjoyed this teardown of this Siemens Polyphos 30 X-ray system teardown. Unfortunately, it did trip the mains breaker when I tried to turn it on, so we could not have a little fun with it at first. But at least it was a massive piece of machinery to take apart. So I hope you enjoyed it. So until next time, see ya.